Hello guys, welcome back to the CCNA routing and switching video series. In this video we will be having a look at the voice VLAN. The two main objectives for the voice VLAN, or for this video, will be to understand what the voice VLAN is, why we need to implement it, and then to be able to configure the voice VLAN on a Cisco switch. So to begin with, what is the voice VLAN? So the voice VLAN is a feature that allows us to configure two VLANs on an access port. A data VLAN for our computer or a laptop, and a voice VLAN for our IP phone. Now I know what you're thinking, why would we want to do that? So if we look on any desk in any office, you will probably see two devices on that desk. You'll see an IP phone and a computer. And so if you check it out, you will probably see that the computer has got an Ethernet cable running from the computer into the IP phone, and then from the IP phone we have a cable running from the IP phone into the switch port. So it's actually the IP phone which plugs directly into the switch port, and then the desk phone plugs into the IP phone. The other option that we can have is to have a separate cable for our desk phone and a separate cable for our computer. Now, the way that this works is that IP phones, or most IP phones, whether they're Cisco, Mitel, etc., they will have a 3-port mini switch built inside that desk phone, the IP phone. We will have one port which connects to our switch, one port which connects to our computer, and one internal port which connects to the IP phone. Now your computer is going to send traffic to your switch untagged. Your desk phone will send traffic to your switch tagged. And this tagged traffic is considered part of the voice VLAN. So now let's break it down. So why is your IP phone sending your traffic tagged? So the reason why an IP phone sends you is traffic tagged is because when we add a DOM1Q tag to an Ethernet frame, within that tag there's a field called, I think it's the priority field. It's 3 bits in length. That priority field allows us to perform quality of service or class of service. Essentially allows us to take a frame and, based on what that field is set to, treat that frame better or worse than another frame. Now, with voice over IP, it's recommended that we have to allow good quality voice phone calls, that we treat voice traffic better. Now in a network which isn't congested, you probably won't have to do any quality of service or any class of service. The reason being is because the network isn't busy enough for the congestion to have a detrimental effect on a voice call. However, if your network is congested, your voice traffic or your voice over IP traffic can suffer because frames will not be forwarded in a timely manner, meaning that voice phone calls will suffer and you'll get constant drops. So the voice phone call isn't going to be of good quality. Now, by sending the traffic tagged, it means that we can actually apply class of service or quality of service to frames that we receive on the access port, because the IP phone will be tagging those frames with a VLAN tag. And so we can prioritize voice traffic received from the IP phone over traffic received from the computer, because we can wait a bit longer for a web page to load or for a file to transfer. But if we wait a bit longer or add some latency onto voice traffic, it's going to have a really bad effect on voice traffic and essentially make it terrible. So without the voice VLAN, we would have to plug our IP phone into one port and a desk phone into another port. Now with the voice VLAN, so this whole block here represents the IP phone, okay? So the IP phone has got a mini switch inside, okay? It's got an internal port which plugs into the IP phone, and it has a external port, 2 external ports, one which runs into the computer and another which runs into the switch port. And so what this allows us to do, it allows us to connect our computer into the IP phone and then run a cable from the IP phone into the switch, allowing us to only take up one switch and support the IP phone and the computer over a single access port, and allows us to support 2 different VLANs on a single access port. And so the way that this would work is that your phone is going to be tagging traffic with the voice VLAN that is configured on that port. So in this case, we would configure the voice VLAN as being VLAN 10. Now, how does the phone know to tag traffic with VLAN 10? Well, there's a protocol called CDP. A CDP allows this switch to communicate with the IP phone and basically tell the IP phone, the voice VLAN configured for this port is VLAN 10. I want you to start tagging traffic with VLAN 10. Okay, so any traffic the IP phone sends is going to be tagged and is going to be assumed to be part of VLAN 10. Any traffic that the computer sends will be untagged and will be assumed to be part of the data VLAN. So switch port access VLAN, that's the VLAN that the data sent from the computer will be assumed to be a part of. Okay, and then by separating or by using a VLAN for the IP phone and using a VLAN for your computer, it also provides a security mechanism as it keeps the traffic separate. We cannot access or contact our IP phones directly. We'd have to go through a later device, and also reduces the amount of broadcast traffic our IP phones receive because they're on their own separate VLAN on their own separate subnet. So, like I said before, it allows us to isolate voice and data traffic by putting them into separate VLANs, and limits the broadcast your IP phone needs to process. It also allows us to apply quality of service on voice traffic as it comes into the switch tagged. This is important in congested networks to ensure high quality voice calls, and the double queue tag, reason being, has a priority field which allows us to provide better service to different traffic. A normal Ethernet frame doesn't give us this ability. So the configuration is pretty simple. We would define the voice VLAN first with the command VLAN number, then we would define the voice VLAN for switch port with the command switch port voice VLAN number, and that's it. That's it. Obviously, the command switch port access VLAN is going to be the VLAN assigned to your computer, and the voice VLAN is going to be the VLAN assigned for your IP phone, but that's literally the commands that we need. And then to verify, we use the command show interfaces interface. Okay, now I'm going to pause the video. When I come back, I'll show you how to configure this setting on a Cisco switch. Welcome back, guys. So I'm now on the console line of a Cisco switch. So the first thing we need to do, we need to move into global configuration mode, and we need to define our voice VLAN. So we use the command VLAN and the number, so in this case VLAN 20. We can give it a description as well, so we can just say, we'll give it a name, name voice VLAN, so voice underscore VLAN. Now once we've done that, I'm also going to define another VLAN. Let's just say this, so VLAN 10 is going to be name data VLAN, so data VLAN. And all we would do to set this up is we would go under one of our interfaces, in this case interface FA0/1, and we would use the command switch port mode access to convert it to our access port, switch port access VLAN 10, and the switch port voice VLAN, then we would define the voice VLAN as 20. And that's all there is to it. And then to verify, show, Control Z, show interfaces FA0/1. If I scroll the way down over here, so I think it's switch port, switch port. Yeah, so show interfaces FA0/1 switch port. If I scroll all the way down to over here, should be able to see over here, where is it? This should, yeah, here it is. So voice VLAN, I can see it tells me what VLAN has been set up as the voice VLAN. Also tells me what is the name of that VLAN as well. So if I do a show running config interface FA0/1, as you can see, it shows me the data VLAN is VLAN 10 and the voice VLAN is VLAN 20. Span tree port force has been enabled on this switch port, and that's all there is to it, really. So guys, that's all there is to it. So in this video, we learned about what the voice VLAN is, why we need it, so that an access port can support two VLANs. We learned why IP phones send their traffic tagged. The reason being is because there's a priority field which we can use to provide class of service and essentially give traffic received from the IP phone better quality of service than traffic received from our computer. I hope you have enjoyed this video. If you found this content useful and would like to see more content like this, then please subscribe to my channel. If you found this video useful, then please share so that we can get high quality IT training to the masses free of charge. Thank you very much for watching.